Hello and welcome to today's Royal Society Publishing video podcast. I'm joined by Doctors Michael Dee and Alice Stevenson in the Petrie Museum of Egyptian Archaeology to discuss their Proceedings A paper, An Absolute Chronology for Early Egypt using radiocarbon dating and Bayesian statistical modelling. This paper uses radiocarbon and archaeological evidence and applies a statistical model to produce an absolute timeline for the formation of the Egyptian state. So, for those of us who aren't that familiar, what exactly is Egyptian chronology and why is it so important to archaeologists?
Well, in a chronology, and the chronology of Egypt is a timetable. It's an ordering of the kings of Egypt, essentially a political ordering that includes the lengths of their reigns. So ever since classical times, people have been putting together a historical chronology for Egypt using textual remains, archaeological remains, to essentially form a backbone of the history of Egypt as far back as what we call the Third Dynasty. The period before that, when the state was formed, much less is known about, and that's essentially what we wanted to analyse using scientific techniques, essentially where the documentary and written evidence is quite scant.
And this is one of the problems that the famous archaeologist Flinders Petrie first faced in 1899. His teams had excavated thousands of pottery vessels like the ones behind me here. But there was no temporal framework. There was no sense in which these things could be ordered. And Flinders Petrie was one of the first individuals to use mathematical modelling, together with theories of cultural evolution, to create some kind of order using all of this pottery. And that sequencing of pottery has really been the backbone, a relative dating sequence that archaeologists have used and has allowed us to look at the direction of social change. But the problem was, it's an ordinal scale. It doesn't tell us anything about the pace or the duration of that change. And for that, you need radiocarbon dating or other chronometric techniques.
Statistical models have previously been used in Egyptian chronology. Why is Bayesian modelling so well suited to this, and how does your work expand on the models already available?
It's particularly useful in radiocarbon dating because radiocarbon dates are not, strictly speaking, dates in themselves. They're measurements of isotopic ratios of the material, the sample material, measuring the proportion of radiocarbon relative to ordinary carbon in a sample. That individual isotopic ratio, in order for it to be turned into an absolute date on the AD-BC timescale, it needs to be compared with a reference set of measurements, which is essentially based on individual tree rings from years back through time. So we know what the proportion was of radiocarbon at any given point in time. So the isotopic ratio in your sample is compared with that reference material, and then you get a date on the absolute timescale. And that date at that time is no longer Gaussian, it's multimodal and quite hard to interpret, and essentially impossible to do much classical statistics with. So Bayesian modelling allows us to take those probabilities, bundle them all up together and apply new statistical approaches to that data set. In addition to that, Bayesian modelling allows us to introduce into that equation information that we have from archaeology or other sources that is chronological information, but not necessarily absolute information. It might be things like ordering of different phases of an archaeological sequence. And as long as we can express that information mathematically, we can build all of that into our Bayesian model, which is all calculated on a computer program, and end up taking these relatively irregular probability functions that represent the dates and refine them, really narrow them down to make them more precise and more appropriate for sort of archaeological analysis.
What do your results show, and how do they differ from the previously accepted chronology?
Well, there's two or three sort of main things that our project discovered, and I'll just start with saying we've got a chronometric date for, a scientific date for the formation of Egypt when the territorial state of Egypt, essentially from modern-day Aswan right up to the Mediterranean, was formed. And our estimates place that between about 3100 BC to 3050 BC, peaking around 3080, 3090 BC. And the sort of second main conclusion of our study was that the period leading up to the formation of the state, which we call the pre-dynastic period, is much shorter than people previously thought. We placed the beginning of the pre-dynastic period around 3800, 3700 BC, which is as much as 200 or 300 years later than a lot of previous studies, which in many respects were based on very little scientific evidence and essentially just best reckoning. So this shorter pre-dynastic period has particular implications for the formation of the Egyptian state.
I mean, to put that in archaeological context, really in the 4th millennium BC, what we see is a transition from pastoralist, seasonally mobile communities becoming much more sedentary through the 4th millennium BC, becoming more committed to cereal production, and yet by the end of that millennia, we've got a territorial state headed by divine, or what is seen to be divine kingship. And what these results show is that really profound change in social complexity and political centralization occurs really quite rapidly, perhaps more rapidly than had been previously acknowledged.
Radiocarbon dating is likely to show some contamination in the samples. How did you deal with this?
Well, contamination is a problem in radiocarbon dating, not so much as perhaps people might think. We have pretty sophisticated pre-treatment methods now that we apply to our samples and essentially try to extract from the sample the material we think will be least affected by contamination because it's been least modified in the soil or wherever it's been kept over the duration. For example, with bone, we extract the proteinaceous fibers, the collagen, from inside the bone, which is less likely to be affected by, for example, exterior glues and that sort of thing.
This is very multidisciplinary work. Can you tell us a bit more about the collaborations that were involved in this project?
There was a vast number of people, actually, on a practical level. Currently, it is impossible to gain any samples directly from the field in Egypt due to legal restrictions. So we were very reliant on gaining samples from museum collections. And so there was a lot of dialogue with museum professionals across the UK and internationally as well to acquire the best samples. And that in itself takes archaeological research to make sure you've got a secure context that you can for that material and really researching the history of that material.
We had the director of the radiocarbon facility, Professor Christopher Bronk-Ramsey, whose modelling application we used, and it's a very popular Bayesian modelling application, which has enabled a lot of this research to go forward. On the other side of the scale, we had Professor David Wengrow here at University College London, who contributed a lot on the theoretical side, the anthropological side of the analysis, and all sorts of other scientists and academics involved, including a material scientist, Dr. Andrew Shortland, a chemist, Dr. Fiona Brock, and a geneticist. We actually at one point attempted to try and get some genetic information from the Egyptian material we were dealing with, Dr. Linus Gertland-Flink, who works at the Natural History Museum. So a range of different people from a range of different fields.
So what next? How would you like your work to impact the archaeological community?
What we'd like to do is inform people a little bit more about these techniques, about Bayesian modelling, about using radiocarbon dating correctly, and trying to get the very best results you possibly can for the sites and contexts you're interested in.
Yeah, and I think what hopefully this data in this paper and other papers that might lead from it was the opportunity to ask new questions, especially of this data. There's been a lot of energies, particularly in the archaeological community, focusing on pottery typologies. But I think with this independent technique of estimating age, estimating durations, we can really start to broaden our perspectives and, as I say, ask new questions about the material we've been excavating and that's in museums around the world.
Thanks, Michael and Alice, and thank you all for watching.